Okay, so again, happy Friday. Oh, why did the timer start again? No. Okay, so one thing somebody noticed, they sent it to me in the chat. They're like, Mister, we need to write a scale factor, right? And I said, yes. And they said, okay, but Mister, you said yesterday a scale factor is a ratio. I said, yeah, that's why it says ratio in the in parentheses. They're like, okay, but which one do I put on the top and which one do I put on the bottom? You told me yesterday that if you see a problem, they're going to tell you which one goes first, which one goes second. And I look at these instructions and none of them, it just says find the scale factor between the two figures. It doesn't say find the scale factor between the big and the small or the small and the big. So I don't know which one to do first. So if the problem doesn't give you which one goes first and which one goes second, then you can choose. You can do if whatever you want. You'd have to choose though. You'd have to start from the beginning and look at the picture and say, okay, this one's the small figure. This one's the large figure. And then for you, you're going to have to say to yourself, okay, the problem doesn't tell me which one goes first. So I'm going to choose. I'm going to do small to large. And then we may have another student that says, no. I'm going to do large to small. Neither of them are incorrect. Neither of them are incorrect. The directions didn't give you specifics, so you can do it either way. Right? They're going to tell you different things. Small to large, large to small is going to tell you how much smaller a figure is or how much bigger a figure is. That's all. So let's do both. Let's do both. You didn't have to do both, but I'm going to do both to show you that you could have done it either way because this question doesn't give you an order. Most questions will, though. Most questions will, so pay attention to that question. This one didn't. So let's do small to large. So I don't know if you noticed, but I color-coded the sides. Right? So that way you can know which sides match which side. The red with the red, the blue with the blue, the purple with the purple, and the green with the green. So let's look at this. So what we're doing is we are comparing small to large. We're making ratios of the sides. The small one to the large one. That's what we're doing first. So let's do the red one first. So small is 8. And which one matches 8 on the large one? So small is 8. I want to make a ratio. Which one matches the 8 on the large quadrilateral? Hello? Is my microphone on? Hello? Hello? Testing, testing. So I'll ask it again. We're going small to large, so I'm choosing this side, 8. So I put 8 here. So which one matches 8? Exactly, 12. So that's 8 to 12. Okay, and I can simplify that, can't I? What's 8 to 12? What can I divide? What can I simplify 8 over 12 by? By 4. Good job. By 2. Yes, you can do by 2, but let's try to get the biggest number. Let's do it by 4. So divide by 4, divide by 4. So this becomes 2 over 3. That's the ratio of the red sides. All right, let's do the blue sides. Let's try the blue sides. Here's 4. What side matches 4 on the large triangle? Because we got to do small first. I put small on top. What side matches 4 on the large triangle? 9, 15, or 6? 6. Very good. Very good. Hold on. Good job. Good job. So it's 4 to 6. And if I simplify that, what can I divide 4 and 6 by? By 2. Very good. And I get 2/3. Okay, so far so good. Now, you can stop here and say, ooh, I know the ratio already. It's 2/3. It's 2 to 3. It's right there. But there's some people out there like, no, mister, we need to try all 4 sides and make sure all 4 sides grew or shrunk at the same rate. Okay, I agree with you. Let's try all 4 sides. What? What's wrong with that? No. No, they're not a nerd. They're just being thorough. They're making sure that it is 2/3. So let's check. So on the small triangle, I'm going to pick the purple. So that's 10. And what does the 10 match with in the large? Right? We're going to put small in the top, large in the bottom. 10 matches with 9 or 15. Come on. It's color-coded. It's pretty obvious. 15. Perfect. So it's 10 over 15. And if I divide by 5, I get 2 over 3. Woohoo! We're almost there. Some of you might say, mister, that's enough. 3 of the sides give me 2/3. When I match up 3 of the sides, the red ones, 8/12 is 2/3. The blue ones, 4/6 is 2/3. The purple ones, 10/15 is 2/3. That's your ratio, right? This is proportional, mister, because they're all equal. But again, we need to be thorough. So let's be thorough. Let's match 6 with 9. So small, 6 over large, 9. And so if we divide by 3, divide by 3, divide by 3, we get 2/3. So we notice all the ratios are equal to each other. If all the ratios are equal to each other, this is a proportional growth. So we can say in words, because we chose small to large, the scale factor, which is ratio, right? Which also means the rate that it shrunk or the rate that it grew, whichever way you're going. The scale factor from small quadrilateral to large quadrilateral is 2 to 3, or how do we say it? 2/3. Right? It's 2 to 3 or 2/3. And usually we just say 2/3. That means the small quadrilateral is 2/3 the size of the big one. Mister, yeah. I did the other way. I did large to small. Okay, that's fine. So let's do the same thing. So let's look on large to small. So we know the red. We just put large in the top and small on the bottom. That's 12/8. And that simplifies to 3/2. Then we have the blue, which is large to small. We go 6/4 now, right? 6/4, which is 3/2. Then we look at the purple. We look at the purple and we say large. The large is 15 over the small, which is 10. And if I divide by 5, I get 3/2. And then we do the green. Same thing, large, which is 9, over small, which is 6. And if I divide both by 3, I get 3/2. So you can say the scale factor, right? We can say this whole sentence again, but we can just say the scale factor of large to small is 3 to 2 or 3/2, right? 3/2. And if you did the math, 3 divided by 2 is 1.5. So that's basically saying the large one is 1.5 times bigger than the small one. Now, did you have to do both of them? No, you did not have to do both of them. But one thing we did want to make sure was that all the ratios of the matching sides, match, no matter which one you did. If you did small to large, you got 2/3, and they all are 2/3. If you did large to small, you got 3/2, and they all are 3/2 because they grew at the same rate. The sides grew at the same rate or the same ratio. Remember, rate is short for ratio. Rate is just short for ratio, and the rate that this is growing is 3/2. Okay, does that make sense? So I'll give you a minute to copy this down and ask any questions. And then we're going to focus on matching up the figures, because some of you are having trouble matching up the figures. So we'll talk about that because that's very important. Yes, we're going to figure out and we're going to calculate lengths of sides and stuff, but I want us to match up the corresponding parts first. Okay, but I'll give you a minute to copy this down or ask questions, because I know some of you like to listen before you write this stuff down. So somebody wants me to focus, wants me to zoom in on this one first, and then I'll zoom in on the other one. That's fine. The blue says the scale factor ratio from small quadrilateral to large quadrilateral is 2 to 3 or 2/3. You still can't see it? Or did I write sloppy? I can write it neater if you want me to. Just let me know what you want. You got it? Okay. Yeah, if I'm writing too sloppy, let me know, because, I know when I write too fast, I'm sloppy. So I'll focus on this, and then In about 10 seconds, well, when it's at 30 seconds, I'll go focus on the other one. Okay, let's go over here. This is what this one says. Okay, time's up. So now, let's take out our notes. Let's take out our notes. Okay. Uh-oh, why do I have a black screen? What's going on here? So go ahead and get to your notes, however you do it. There we go. Okay. So yesterday or 2 days ago, we did the green part. We discussed similar polygons. We discussed what it takes for polygons to be similar, and all the angles have to be congruent, right? When I zoom in or zoom out on something, I can't change the angles because that'll change the shape. And similar figures have the same shape. One is just bigger, one is just smaller. And then the corresponding sides are proportional. Like we just saw in the warm-up, they grow or shrink at the same rate, at the same ratio. You got to make sure all those ratios of comparing the sides are the same. That's the same rate, and that's called the scale factor. That ratio that you find between the two figures is this scale factor. And then perimeters also. We're not going to focus too much on perimeters, but that is also a fact that the perimeters are also growing at the same rate, at that same ratio, at that same scale factor. Then we talked about scale factors. Whoa, excuse me. I need some water. So scale factor, order matters. We talked about order matters when we talked about scale factor. And in the warm-up, they didn't tell you the order, but if we look here at yesterday's examples, right? In yesterday's examples, they gave you an order. They said, what is the scale factor of this triangle to this triangle? So if we look here, we see, oh, ABC is the small one, DEF's the large one. So they want us to make a small to large comparison, and that's why we did this, put small on the top because small was first. And then question 2 just flipped them and said, now I want to look at DEF and compare it to ABC. They want to go from large to small. And so always pay attention to the question they're asking. Whichever one they say first in the question is the one you put at the top. First always goes on top. And that's how you make your ratio. Because some of you people are asking me, Mister, that's the biggest question I've been getting the past couple of days. How do you know which one goes on top? How do you know which one goes first? Well, you look at the question, whatever it says in the question. So over here, the small one was first, so we got 2 to 3. Over here, the large one was first, we got 3 to 2. Okay? And then we looked at the perimeters, but that's not as important. And so now we're going to look at, what if they tell you two figures are similar and they give you a similarity statement? Can you tell me which parts match? Okay, well, this is what we did when we did congruent triangles. Before you can solve for anything, you need to know which parts match. And we kind of did this yesterday, right? We said, okay, A is first here and D is first there. So guess what? A and D are matching. B is second, E is second, they match. C is third, F is third, they match. So we're going to do that here. So let me show you what I'm talking about. So before we do that, these problems are going to give you a similarity statement, meaning they're going to tell you which things are similar. Okay, so you need to know the symbol for similar. This little squiggly line means similar. That's the symbol for similar. So when you see like triangle HIJ, and then you see this little squiggly line, and then you see triangle KLM, that means they are similar. One's a bigger version of the other, or one's a smaller version of the other. And so if I want to write a valid similarity statement, you must match the corresponding angles and sides. You must have the same order. So if I look up here, I can say triangle, right, the problem from yesterday, triangle ABC is similar to triangle DEF because that's what they were telling us. These were matching. These were the matching parts. Okay, so that's how we write a similarity statement. When you see the similarity statement, this is telling you that this one matches with this one matches with this one, and this one matches with this one. You're putting it in the same order, the stuff that corresponds. The word is corresponds, but we also say matching. Okay? So using a similarity statement, let's match up everything. So let's look at this. So what I like to do, like we did with congruent triangles, is I like to use color. Okay, it's going to make your life so much easier. If you just keep it black and white like this and you write black and white on top of it, it's not going to make as much sense. Let me show you what I mean. So I have triangle JKL is similar, that's what this means, similar, is similar to triangle PMN. So what I'm going to do is I'm going to use color. So since J is first here, P is first there, guess what? J and P are matching parts. K is second, M is second, so K and M are matching parts. L is third, N is third, so L and N are matching parts. So there you go. Now I have it color-coded. I have the picture color-coded, so now I know what matches with what. So now I can, over here in the table, write my angles. Remember, when these two figures, if they're similar, and they are similar, because guess what? That symbol means, oh my God, I can't draw. I can't write. Similar. That symbol means they are similar. So since they're similar, that means the angles are congruent. The matching angles are congruent. So we know which angles match with each other. Purple with purple. Angle J is congruent to angle P, because those are the matching corresponding angles. Then let's look at green. Angle K is congruent to angle M, because those are the corresponding or matching angles. And then lastly, angle L is congruent to angle N. Okay, so that's it with the angles. But now we need to do the sides. And the sides are not congruent. The sides are not congruent. What are the sides in similar triangles? Let's go back up here. The sides are proportional. That means I got to make some ratios. The sides are proportional. That means all the ratios are the same. So I got to make a ratio of sides. So how am I going to do that? Well, which one are they doing first? If you look at this picture, this one's the small triangle. This one's the large triangle. Are they going from small to large or large to small? Well, let's look up here. Which one did they put first? They put JKL. JKL happens to be the small one. So they're going from small triangle to large. So that's what my ratio is going to be, small to large. If you don't know what the ratio is going to be, always look at the problem. Whatever order they put the problem is, that's how you're going to do your ratios. So now let's do our ratios. One pair of sides. So let's look. How are we going to do this? Well, let's let the colors help us. If you don't know which sides match with which sides, yes, my voice cracked. I know some of you are like, haha, Mr's voice cracked. Yes. I know my throat is very dry this afternoon. I'm sorry. Okay, so use the colors. So I'm going to do JK, because I'm starting with the small triangle. So I'm going to do purple to green, which is JK. And what does that match with? What is JK? What does purple to green match with in the large triangle? Well, just go purple to green, and that's PM. Right? That's the ratio of match. You just got to put a ratio of matching sides, right? The ratio is just matching side over matching side. And we're putting small on the top, and large on the bottom, because that's the order they gave it to us. So those of you asking, Mr., why did you put purple, green, JK on the top? Because that's the small triangle, and that's the first one here. And then it matches with this purple, green, which is PM on the large triangle. And that ratio, if this is truly similar, and it says it is similar, that ratio has to be equal to the other ratios. Well, let's do another ratio. Let's do green-orange. Green-orange, which is KL. KL. And then let's do green-orange over here. Green-orange, which is MN. There you go. Now that ratio has to equal the other sides that match. What are the other sides that match? Orange, purple. Orange, purple. We didn't do orange, purple, did we? So orange, purple, and the small one is LJ. LJ. And what does orange, purple match on the other one? NP. NP. Okay, so all we did is we looked at this. We looked at this similarity statement, right? This is a statement telling you what is similar. This is the most important thing because it's telling you that's what's similar. And it's giving you the order. So the first one matches with the first one. The second one matches with the second one. The third one matches with the third one. And I would use colors to color up those corners. And then the angles have to be congruent because when things are similar, the angles are congruent because if you change the angles, you'll change the shape. And then the sides have to be proportional. How do we do proportions? Just compare the sides. And we're doing small to large. So we just say purple, green, purple, green. That's JKPM. Then we did green, orange, KL, MN. Right? Small on the top, large on the bottom. Then we did the last one. Orange, purple, LJ, and P. LJ goes in the top because that's the small triangle. And P goes in the bottom because that's from the large triangle. So you're just making ratios of the matching sides. That's it. Now, once we have this, once we know what matches, then we can start making equations and stuff, right? I can get these two and make an equation, or I can get these two and make an equation. Or I can get this one and make an equation because all three of these are equal to each other. All three ratios. They all have to be. Just like our warm-up, right? When we went to our warm-up, we had four sides. Weren't all four sides equal to each other? No matter which way we did it, they're all four equal to each other, and that's exactly what we're doing here. So I'll give you a minute to copy. Then you're going to do this. All this is, you're not solving anything. So some of you are like, what, mister, what's the answer? There is no answer. I'm just making sure if you can look at a similarity statement, can you match the pieces? Can you match the pieces? Can you tell me what angles equal each other? Can you tell me what sides are proportional to each other? Okay, so I'll give you a minute to copy this down and ask any questions if you're lost. All right, so nobody had questions, so here's what I'd like you to do. I'm going to skip 2 because 2 is a little tricky. I want to talk about 2 in a minute, but I want you to try number 3. I want you to tell me what angles are congruent, and then I want you to give me the ratio. There should be 4 of them, right? Just like this one, there should be 4 of them, 4 ratios. So I need to see this equals this equals this equals this. I need to see 4 ratios, okay? And then 4 angles equal to each other. So use some color. I'll give you 4 minutes to try this yourself. Do exactly what you did in number 1. Tell me what angles equal each other, and tell me the sides that are matching, and make a ratio with the matching sides. Okay, we're making ratios with matching sides. And just follow the colors. If you don't know which sides match, follow the colors like green, red, yellow, orange, whatever you choose. Okay, let's give you 4 minutes. Starting now. Hopefully you're not stuck, but if you are stuck, the first thing you should do is match up with different colors the different points. All right, time is up. So the first thing you should do is you look at this statement. this similarity statement. This is telling you what is similar. So you have quadrilateral JKLM is similar to QRSP. And so that order matters. So that means the J and the Q match because they're both first. So I made them both purple. And then I did that on the diagrams. The K's are both, the K and R are both second. So K and R match. So I painted them green. And I did that on the diagram. L and R are third. So they match. So I painted them orange. And I did that on the diagram. And then M and P are last, so they match. So I painted them blue, and I did that on the diagram. And if I look here, this is the small quadrilateral, and this is the large quadrilateral. And so they're going from JKLM to QRSP, so they're going from the large one to the small one. You see how they did the large first? So all my ratios are going to be large over small. Does that make sense? Because they said it first, so the large one's going to go in. So when I go down here and do my ratios, right, and I should have 4 of them, large is going to go on top, small is going to go on the bottom. Okay? The colors should help you out. The colors should definitely help you out because now you can see, oh, I know what angles match. Angle J, the purple one, is congruent to the other purple one, angle Q, because they're both first. Let's go next. Angle K, which is the green one. Uh-oh. This isn't real ink. Why does it look like I'm running out of ink? Angle K, which is the green one, is congruent to angle R, which is the other green one. We're just matching up the pieces to the two figures. Angle L is congruent to angle S, because they're both orange. They're both third in the list. And then angle M is congruent to angle P. Easy, right? So now let's see which sides match. So again, we're going to go this side first over the matching side over here. So let's do purple green first. Purple green, which is JK. That's purple green. And then what's purple green in the other one? Purple green is QR. QR. So JK matches the QR. That's my ratio. Large side over small side. All right, let's do the next one. Let's do green, orange. I like to go in a circle. I like to do this one first, and then this one next, and then this one next, and then that one last to get my 4 ratios. So let's do green, orange. Green, orange is KL. Green, orange is KL. And let's do green, orange in the other one. Green, orange is RS. So that matches, KL matches with RS. Large on the top, small on the bottom. All right, let's do the next one. LM, which is orange, blue. Orange, blue. LM is orange, blue. So what's the orange, blue in the other one? Orange, blue is SP. SP. And then the last one is blue, purple. MJ, Michael Jordan. MJ. So that's blue, purple, right? Don't forget blue, purple, MJ goes to blue, purple, which is PQ. And there you go. There you go. Give you a minute to copy that down or ask any questions if you're lost. I'm telling you guys, doing the colors, doing it with just setting up your colors and matching which angles match with which angles, which points match with which points, makes your life so much easier to know what matches. Don't worry about, like some people think, oh, mister, using crayons or coloring things in high school or even in college, that's babyish, right? No. Did I tell you the story where I sold my notes in my economics class? Because, excuse me, I took economics and I would take notes. I had highlighters and colored pencils out because there was a lot of graphing going on, right? And in the economics class, it was microeconomics. So it was a lot of specific things. So he would draw a graph. I remember my professor would draw a graph, and then there was a whole bunch of things going on in that graph. And so if you drew it with black and white, which he did on his diagram, he would do just black and white on top of black and white. And so everything just became a mess because it was all black and white. Well, I would take my notes. I had a little ruler And I'd color, I say, okay, this one is orange. Okay, I'm going to make this one purple. I'm going to make this one yellow. And when you saw my notes, you can tell and you can say, oh, this is going on. This is the supply here. This is the demand. This is the equilibrium. So you can see everything. So I passed this class. I did really well in that class. And then next semester, he told me, he called me and he said, hey, someone needs tutoring. Would you tutor? I'm like, sure. And then I tutored this kid, and I met at the library, and as I was tutoring him, I was using my notes, and he's like, hey, I like your notes. I'm like, oh, thank you. He's like, could I buy those from you? I'm like, sure. So instead of tutoring him the whole semester, he just bought all my notes because they were all colorful and neat and organized. And this was college, and I had highlighters, and it was colors because that helped my brain understand things more. And so I made like $75 just from my notes. So don't feel like, oh, this is kid stuff using crayons. And no. If it helps your brain understand, it's good. It's good. Okay, so let me go here really quick. I want to show you something. Triangle. This is telling you triangle XYZ. So that's this one right here. XYZ is similar to triangle RYS. And if you look here, RYS is this small one here. And if you notice, these triangles are on top of each other. So what I like to do, which make my life easier, is I like to separate them. I like to draw the big triangle here and label it the way I need to label it. And then I like to draw the small triangle right next to it. Right? I like to separate them so you can see them a little better. And then start looking at the matching parts. Right? Then start looking at the matching parts. Like saying X and R, Y and Y, Z and S. And then you can start doing that. Because some kids get confused seeing it together like this, but you are going to see triangles on top of triangles, quadrilaterals on top of quadrilaterals that are similar. So just warning you. So to do this, I would separate them. But guys, I apologize. We are past class time. It is 2:17, so I apologize. So we will continue this on Monday. I did put the homework, and I did put some classwork in the folder. You can start on the homework, but the homework will not be due until, I think I'll change it. It says Monday, but I think I'm going to change it to Tuesday. Okay, so everyone, sorry I went over. Take care. Have a great weekend. Have a great rest of your Friday. Miss Rivas, thank you again for your help. I appreciate it. Enjoy your weekend. Thank you. All right, take care, everyone. Bye.